This video is an introduction to working with data that originates on the web. To do that, you'll need some conceptual knowledge about how the web works in the first place, and then we'll get into making requests to web servers, which ultimately return data in formats such as JavaScript object notation that you can process further. Those are generally called Web Application Programming Interfaces, or Web APIs, and we'll be exploring several freely available ones. The web, which of course is slang for the internet, is really a network of physical devices that communicate via a standard known as Internet Protocol, which involves routing small messages called packets through many points because the network is sparsely connected, meaning that any given device is probably only connected to a few others in the network. In practice, this is quite similar to how ordinary mail is sent. The sender puts the message in an envelope and writes the address and return address on it. Then they send it out via their local post office. Then it is routed through many other post offices until it arrives at the target destination, where it's opened and read. Also, similar to the mail, sometimes packets get lost. The addresses are called IP addresses, and now they come in two varieties. The one you're likely familiar with is IPv4, which is a 32-bit number, and the new one is IPv6, which is 128 bits. IPv6 is enough addresses for every particle in our galaxy, so it's future-proof. IPv4, however, is still widely used. In either case, there are both public and private addresses, which are designed to be used on local networks. Typically, you pay for a public address on the internet, and then set up your own local networks with private addresses. We'll discuss this more later. One other interesting fact about IP addresses is that they tend to change. They're also a bit difficult to type, and for that reason the domain name system is used to map human-readable names to various numbers, which are typically IP addresses. Domain names are read in reverse. You have top-level domains such as com, edu, and org. Then you have second-level domains, which are typically an organization. The combination of a second-level and first-level domain is what you might purchase from a domain registrar. The registrars are responsible for mapping the domain names to specific servers on the internet that hold the records for that domain name. These are called name servers. The network of name servers all synchronize with each other over time, and your computer knows how to reach some of the name servers to ask for information about domain names, which is called resolving the domain name. The diagram below, pulled from Wikipedia, illustrates this process nicely. If your computer is trying to find wikipedia.org, it first asks a root name server, which then sends you to the org name server and finally the wikipedia.org name server, which can say what IP address www.wikipedia.org is at. As I mentioned before, Internet Protocol sends messages between computers. However, a modern computer runs many applications on it. For that reason, there's a layer on top of Internet Protocol called the transport layer that's designed to allow for individual applications, sometimes called processes, to send and receive data. They do so through what's known as a port. Ports are a bit like post office boxes. Once the message arrives at the post office, it's placed in a specific box, and only the person with the key to that box can get it. Now, there are two transport layer protocols that are widely used: User Datagram Protocol, also known as UDP, and Transmission Control Protocol, TCP. UDP is a very thin layer on top of IP, essentially adding just the port. TCP, on the other hand, requires the network to deliver every byte in order to the recipient. With TCP, packets are still sent, but every packet must be acknowledged by the other side. If it's not acknowledged, the packet will be resent. The other side will reorder the packets and only deliver them in order to that port. This reliability is extremely important for tasks such as sending files over networks. UDP, on the other hand, is used more often when it's okay for a small packet to be lost, such as in voice communications. Now that we've discussed ports, we can talk about network address translation, or NAT. Network address translation is a service offered by routers that allows a private network of IP addresses to communicate through a single IP address. Most homes, for example, have only one public IP address, but may have dozens of devices that connect to the internet. They do so by leveraging the additional port addresses. When a computer on the internal network sends a message to a public IP address, the router that has the public IP address for the household notes the return address that's included with the message and creates a tunnel of sorts to a new port on the public address. It then rewrites the return address on the packet and sends it along. When the response comes back, the router sends the data through the tunnel and it's received by the sender. But this causes a problem. While you can connect to devices that have public IP addresses, you can't connect to other private networks without going through additional steps. While there are several solutions to this problem, such as pre-configuring the tunnels on the router you're trying to connect to, this is called port forwarding, none is perfect, and this makes owning public IP addresses very valuable. Now, all of this is necessary to understand what you'll ultimately be using, an application layer protocol. Application layer protocols use TCP or use UDP, and they're used to communicate higher level information than just the bytes of a message. They follow specific formats for messages, such that the recipient knows how to make sense of what is being sent. They also tend to use well-known ports, so that others know where to connect to for any given server. Some examples of these are listed here, such as the Hypertext Transport Protocol, HTTP, which uses TCP over port 80 by default. But DHCP, the application protocol that enables a router to assign IP addresses to new computers on the network, uses UDP over ports 67 and 68. SSH is a particularly important one for accessing remote machines, and that uses TCP over port 22. These ports can be changed, but it's a good idea to avoid them when creating new application protocols because you don't want to collide with existing services. The specific one we'll focus on is HTTP, which again is the Hypertext Transport Protocol. This is the dominant protocol spoken on the web. Originally, it was primarily used to access documents written in the hypertext markup language, HTML. It features a client-server request-response model, where a client application, for example your web browser, makes a request to a server machine for a particular document, a website. The server then accesses the HTML document and sends it back to the client. It's called stateless because once the response is given back, the interaction's over. No connection or other information is maintained by the protocol. The actual server and client applications involved may remember information, but the protocol doesn't. Every HTTP request is unique. Generally speaking, HTTP requests are one of four types, with the most common being a GET request. A GET request asks for things from a website. By contrast, the other three listed here, the POST, PUT, and DELETE, make a request to add, create, update, and delete things on the server. Most of the information about the request, such as where it's from, what resource is being accessed, and the type of request is all in the first part of the request known as the header. Bulk information, such as a file to upload or a form, is contained in the body of the request. What's returned from a request is known as a response. These also have headers and bodies. Importantly, the header contains a response code, such as 200, which means the request succeeded, or 404, which means the resource couldn't be found on the server. The body then contains the information requested, such as the HTML file. In your web browser or another application designed to work with the web, you tend to initiate communication using a Uniform Resource Locator, or URL. This includes many different parts, most of which are optional, but the ones that aren't are the specific protocol being used, such as HTTP, a colon, and the specific path being accessed. However, more commonly you'll include the host, which can be a domain name or an IP address. Depending on the circumstances, you may also need to send login information or communicate using a non-standard port. A very important piece of information you can include is query parameters. Query parameters are key value pairs separated by the equals symbol, and the pairs are then separated by ampersands. These are useful to modify a request. A good example is a Google search request. It uses a query parameter, q, to set the value being searched for. An important thing to note about URLs is that the various parts have a limited set of characters that are valid. For example, you may need to use a special code to put a space in a query parameter value. For that, you can use a numerical code such as %20, which would include that space because spaces are invalid in URLs. Most programming libraries include a way to automatically escape values, so this is only something you need to be aware of when using a browser. Finally, we arrive at web APIs. Web APIs should be called web service APIs. A web service is made available over HTTP, or more typically the encrypted variant HTTP Secure, HTTPS, and it's designed to provide some functionality to the requester. This could be almost anything, but good examples are those that provide access to real-time data streams, allow you to get pieces of extremely large data sets, or even provide artificial intelligence services such as speech or image recognition. The actual API part is the set of functions made available by the service, again through the HTTP protocol. They describe what data needs to be sent and what will be received. Nowadays, what's received is typically structured text in either JavaScript object notation, which is called JSON for short, or extensible markup language, XML. The API documentation will also indicate how to authenticate requests, which more often than not is done with a special code called an API key that must be included with every request. It'll also say how often the API may be used, and this is known as the request rate. It'll typically be in the thousands per day. While most services can handle many more than that, this limit ensures that no one application dominates the server. To work with all of this in Python, one of the primary tools we have is the requests package. Requests contains methods to make HTTP or HTTPS requests for you from a URL, and optionally a parameters dictionary, custom headers, and files. The web service API will ultimately dictate what goes into these fields to get you the information you want. It will also tell you what you'll get back, and requests will help you interpret that as well. The response object contains all of that information, including the status code and the raw text that was returned, and that's typically what you want. Additionally, because web APIs are so common, requests also includes a convenient way to get a dictionary from a JSON formatted text response. To get going, I've listed some starter APIs here, and we're going to experiment with a few of these. The first one listed here is a quotes API. It's easy to get started with because it has no key required, and the documentation is relatively easy to access. Let me go and look at the documentation. At that website, you'll find this GitHub site. And you can see that there's a variety of methods that you can use to get random quotes, to list the quotes that exist, to get quotes by ID, to list the different authors, to search the quotes, lots of different options in here. And so a number of different ways that you can access this API. Let's take a look at what the Python code looks like. So to get started, we're going to have to import requests. Once I have that, I can make a request by typing requests, then the method, and this is one of get, post, delete, or put. But in this case, the API calls for me to use get. We can see that this is a get request. And I'm going to get https://quotable.io/random. When I do that, I get a response object in return. Within that response object, there are a number of different things. For example, the status code. You can see that it gives me back 200, meaning that this was a good request and the server was able to retrieve what I requested. We can also get the headers. This tells us what is in the body of the request. It gives us lots of information about what was returned. We can also get the text of the body, and that's where the quote is actually contained. though the quote is in this structured text format. And so this is a big text string that has what looks like a Python dictionary inside it, though in reality is JSON. And you actually can know it's JSON by looking at the headers. You can see the content type is application/JSON, although that won't always be consistent, and so looking at the text of the body is the best way to make sure. To get the actual dictionary, we can use a method called .json. And so that'll give us a Python dictionary, and you can see it's now structured a little bit nicer, where we can see the content and the author and things like that in here. And we can grab particular pieces of content by using the dictionary key. But what makes requests usually more powerful is to use query parameters. And so instead of requesting it exactly like this, I can, for example, include a list of parameters, such as I want a particular author. And so let's say I wanted a quote by Winston Churchill. I can run this, and it gives me back a quote by Winston Churchill. Another useful part of this API is that it has paginated results, and paginated results are somewhat difficult to deal with. And so if I get or run requests.get and https quotable.io/quotes, and let's print the results, print the results.json, you're going to see we get actually back a page of results. So this is 20 of results out of a total of 2,042 different quotes. And you can see it's done in pages. But we can access a particular page by including a parameter. So params page, and I could say I want page 2, for example, and this will give me page 2 out of 103. But what if I wanted to get all of the quotes? Well, we can use a Python for loop for that. And so we can wrap this request in a for loop and say for I, or for page, in range of 1, and it looks like there's 103 pages, although I'm only going to get 10 pages because I don't want to overload their server grabbing lots of different pages of requests. And then I'm going to make a request, and I'm going to get a particular page. But what do I do with that page? Well, I'm going to store all of the quotes that I get, and you can see the results has a list of the different quotes. I'm going to store that in a list of quotes. So I'll start with an empty list of quotes, and then I'll get the response, and then I'm going to append quotes.extend, the data that's in the results field. So results.json, and then results. Now I should have a list of quotes, so I'll print that. And so this runs, and we get a giant list of quotes. And I'm going to go on to a new block of code here so that I don't repeat this request. And so I have all of these quotes, and it's a very long list, in a variable called quotes. And now I can turn that into a pandas data frame. So if I import pandas as PD, I can say df is pd.dataframe, and the data frame, dot from records, and then give it a list of JSON data, or a list of dictionaries, and it will turn that into a data frame for me. And we can see that by printing it out. So now we have a large list of quotes. Now what if I didn't want to overload the server? So if I go back up to my requests up here, and I printed it out, so it's printing out literally all the content here, which is quite a lot. And so it's back up here. What I can do is that I can delay each one of my requests. So let's import time. That'll give us the ability to delay. And between each request, I can delay for a little bit. Say time.sleep. And we'll say sleep for 0.1 seconds between each request. I won't print this out so that we don't get all of these this output. but I'm running. It'll take a little longer to get my response back because it's sleeping between each request, just 0.1 seconds, but I could sleep for longer if I needed to. And I have the exact same answer at the end. So now we have a Python data frame, or pandas data frame, that we can process further using pandas. Let's look at a different API now. So let's look at the weather forecasts API. So this is from openmedio.com, and we can go there on our browser, https://openmedio.com, and then /en. You can see it's a free open source weather API, and there's lots of documentation for it. And so you would want to read that documentation and get lots of information on this before you use it, but we're just going to jump kind of right into it because it's relatively easy to get simple weather forecasts from this API. So let's do that now. Down at the bottom here, let's do a result is requests.get, and we need the API they have this URL builder, and we can say, what do we want to get? And then we can see what the URL for that would be. So here's what this looks like. So if we want this forecast here, I'm just going to grab it directly. We can insert this right here. Now I don't kind of like the way that they went about this and putting it in one URL because we might want parameters there. And so I'm going to separately encode the different URL parameters. So I'll hit enter here and save it down here. So we're going to have params equals, and then we'll give it a latitude, longitude, things like that. So latitude, Python dictionary, latitude 52.52, longitude 13.41, hourly, temperature 2M. So I can delete this part here, and let's run the request. I need to close this. So we got a request. It's a response 200, meaning there's something in it. Let's look what's actually inside it. And so we can see we get JSON data, and we're getting what looks like time series data. So let's see if we can better represent this as a pandas data frame. And so the hourly data is where all of the information is. And so we see hourly, and then that itself is an object. You can see time here. And it's a little easier to interpret if we print result.json. So I'll do that now. All right, so we can see time again. So you have all the different times, and then you see temperature 2M. And so you can see that the time and the temperature are the two variables of interest, but we can turn this into a pandas data frame relatively easily. So let's do that now. df is going to be pd.dataframe. And a lot of times I'll just convert it to a data frame right from records, and then we'll process it further once we realize what we actually need to do. And so I can say from records and result.json, and let's print that out. And so this isn't exactly what we want because our hourly and our temperature 2M are not in there. It's actually the hourly is itself a data frame or an object. And so I'm going to go a little bit further into that and say JSON and then put hourly. And now you can see that we grab the hourly, it has temperature 2M and time, and so we have a nice time series data set. We could, for example, set index as time, and we'll do in place equals true. And the result of that, df, is now a time series data set that we can, for example, plot. Right? So if we do df.plot, we get a nice plot of temperature hourly in that particular location over time. Maybe not the nicest plot because we have sort of an uglier time axis here, but you can see the point that the API can give you back JSON data. The JSON data can almost always be turned into a pandas data frame, and then you can go and use pandas from there. So that's a good example of a more sophisticated API. And so that's a very useful one where you can get a weather forecast for any place on Earth. And it'll do its best to give you that over various time series ranges, but it can include other things. That's just temperature. You can do precipitation and other things like that. So very useful API to get weather. The last one we're going to look at is one that requires an API key, because this is very common. And so we're going to look at this alphavantage.co. That will give you stock prices. And so I'll go over to Google and search it, alphavantage. And you can see free stock APIs and JSON and Excel if you want it that way. But in order to use it, you need to get a free API key. So I'll click here, and then I can claim my free API key. Now I already have an API key for this, so it's going to tell me that I do. So I'll say UGA, and here's my email address that I signed up for it with. And I'll say I'm not a robot, and I will select all the chimneys in here. So it looks like there's actually 2 or 3 chimneys, and I will verify that and get free API key. And it's saying my API key is this. And so this API key is free, right? I don't care if anybody uses it, but you can sign up for it yourself. There's not a whole lot else. There's not a whole lot you can do with this that's really problematic. So, but generally speaking, you should hide these API keys, especially if you paid for them. So let's go back over into the into the Jupyter Notebook and see how we can use this. And by the way, if you want to hide a key, it's pretty easy to do. So I'll create a text file, API key, and I'll throw the API key in there, and we'll read it. So I'll say my key is open API key .read. And now it's sort of saved externally. And so if you're using an API key on like a server or something like that, typically you would have the API key stored separately. Maybe it's not in your GitHub repository, for example, and somebody else would have to incorporate their own API key. And so this is typically how I would do that. So now we are going to access this, and let's do a little bit more formal this time. So I'll say base URL is https://www.alphavantage.com. And sorry, this is not a proper string yet. alphavantage.co. /query is the base URL that you're going to use for almost everything in AlphaVantage. And again, all of this is in the documentation for the API. And so if we go and look at the stock API documentation, this you'll see there's various time series and things like that, but pretty much they all work with this /query. And so let's do a query and get the series for a particular stock key. So let's do symbol equals IBM. And the parameters here are going to be params as the function we're looking for, time series intraday. The symbol we're looking for is the symbol. The interval we're looking for is 5 minutes. And lastly, and maybe most importantly, our API key that we're going to use is our key that we loaded already. And so with these parameters, I can make the requests. So my stock request is going to be requests.get, my base URL, and then my params. And let's print stock result dot text.
So you can see we got a very long output. It's time series data set. Time series data set definitely looks like something that we can, again, use pandas with. And so it looks like JSON data as well. So we're going to convert it to JSON and then read it with pandas. So, or convert it with pandas. So let's say df is pd.dataframe.firm records. And we give that the stock results.json. And in particular, the time series 5-minute field that's in that dictionary. And we'll write df. And you can see we're getting a data frame. It's not exactly how I want it. I actually want this column, this to be my index. That's easy to fix. Just put a .t at the end. And that'll transpose it, and now we have a time series data frame for IBM. It'll tell you what the open is, the high, the low, the close, and the volume. And so these tell you the actual stock price on each of these for each of these time intervals.
So, in summary, we've introduced the foundations of the internet leading up to how to use HTTP-based web APIs with Python. This has become the dominant way that data producers provide to others to access their data, and so it's become a vital part of any data science toolkit. To close, I'll note that while the vast majority of web APIs are JSON-based, making them easy to process, technically any website can be downloaded using requests. This can even be used to scrape data from websites that don't provide a JSON output, because HTML is structured data to some extent. There are great libraries in Python to process HTML data, and if you're interested in that topic, just Google Python HTML parser, and you'll find a myriad of tools. But you can also simply use regular expressions to grab specific blocks of text.